You hear that, nature? That's organic. That's some organic nature. You see that? That's some chemistry. Organic chemistry. Boom.
Cycloalkanes are hydrocarbon chains which connect in a head-to-tail or a circular chain called a cyclic hydrocarbon or a cycloalkane. Like such. See, they're in a circle. Carbons, bond. Carbon, carbon.
Cycloalkanes. We're going to go ahead and do our first example here. Example 1 is cyclopropane. So cyclopropane, we're going to start off by recognizing cyclo, and that means we're going to have a continuous chain of singular bonds in a circular structure. And we have prop, which is the prefix for 3, so we know we're going to have 3 carbons. Go ahead and write 1, 2, 3 carbons in a circular fashion. And then the ending ane, so we know they're all going to be singular bonds. So go ahead and put in our bonds here. So now every carbon has 4 bonds. Since every carbon has 4 bonds, we're going to go ahead and look how many bonds these carbons have. So this guy right here and all the other guys have 2 bonds beside them. 1, 2, or for this guy, 1, 2. So because they have two bonds beside them, carbons have 4 bonds, so you take 4 minus 2 because of the 2 bonds. And now they have 2 hydrogens. Like this guy has 2 bonds, 4 minus 2, 2 hydrogens. Same with this guy. And that's cyclopropane. Example 2. Go ahead and write it out. CH2, 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 and CH2. All singular bonds in a circle. So the first thing we're going to want to do, because they're in a circle, we're going to go ahead and write out our cyclo. And then how many carbons do we have? We have 1, 2, 3, 4, 5. So we have 5 carbons. The prefix for 5 is penta. So we're going to go ahead and write cyclopenta. And then our last thing is all of these guys have a continuous chain with 1 bond. They're all singular bonds. The singular bond ending is ane, so we're going to finish it off with ane. So then we have cyclopentane. Example 3. For example 3, we have methyl cyclohexane. Okay, so the first thing we're going to look at is cyclo, so we know they're in a circular fashion. And then the next one we notice is hex. Hex is the prefix for 6, so we know we're going to have 6 carbons. So go ahead and write 1, 2, 3, 4, 5, 6 carbons. We have this ending ane, so we know they're all singular bonds. Go ahead and put in their bonds here. And what I said with the hydrogens before, you're going to go ahead and put your hydrogens in based on how many bonds are attached to each carbon. So right now, each carbon has 2 hydrogens. But we're not finished yet. We have this guy right here, methyl. Methyl, what you're going to do is, because it's not numbered, so we don't have a location for it, it can go anywhere, so just choose any place. Right here seems good. CH3, there's our methyl. But we're not done. This guy right here now has the third bond. So now that he has 3 bonds, we're going to have to remove a hydrogen. So this guy ends up being CH instead of CH2. Example 4, this is our final example. Example 4, we're going to go ahead and write out CH2, 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 and CH2. We're going to go ahead and put all our bonds in. Then we have 2 methyls breaking off here, CH3, CH3. So the first thing that we need to do, because we have these guys right here, the methyls, they're in a set location, so we need to be able to show where they are. By doing that, we're going to write a 1 to show the location of this methyl right here, comma, another 1 to show the location of this methyl right here, and then because we have 2 methyls, the prefix for 2 is di, so we're going to go ahead and write dimethyl. And now, because our carbons are written in a circular fashion, we're going to go ahead and write cyclo. Now, how many carbons do we have? We have 1, 2, 3, 4, 5. The prefix for 5 is penta, so we're going to go ahead and write penta, which represents our 5 carbons. And now every carbon is attached to the other carbons with 1 bond, and the ending we add on for 1 bond is ane. To finish that off, so we have 1, 1 dimethyl cyclopentane.